Hello, I'm Nancy, and this is the OWASP DevSlop Show. On today's show, application security engineer Farah Hawa will introduce us to JSON Web Tokens, their structure, and how they work. We'll also walk through some common attack vectors for breaking JSON Web Token authentication. But first, a short message from today's show sponsor, Pentester Lab.
Pentester Lab Pro makes learning web hacking easier. It covers everything from basic bugs to advanced vulnerabilities. Not only will it help you learn, but you'll also have fun doing it. There's only one way to properly learn web penetration testing, and it's by getting your hands dirty. You'll learn important concepts, not just another bug. You won't need a complicated setup. A browser and a web proxy like Burp or OWASP is all you'll need. Don't wait any longer. The introduction badge makes it super easy to get started. Subscribe to Pentester Lab Pro and get to the next level.
Hello again, Nancy here from the OWASP DevSlop Show, where we meet practitioners from the industry who join us to teach us something new. If you are new here, please make sure to subscribe to our channel and enable your notifications. Note that all the important information that we'll discuss today will be added to the description box below. But let's jump right in. So today's guest is application security engineer at Bugcrowd, Farah Hawa. She's a part-time bug bounty hunter and also creates technical content for bug bounty hunters and web application pen testers. She also interviews some amazing people in infosec for her YouTube channel. But again, before we meet Farah, let me introduce you to my co-host for today, Nikki, Tanya, and our special guest host, Rana. Hello. Hello, ladies. How are you?
Okay. Hi, everyone.
Hello.
Hi.
Yes. So let's introduce ourselves. I think there's a few new people watching us today. So I introduce myself. I'm Nancy, host and project leader for OWASP DevSlop. Tanya, also known as She Hacks Purple. Can you tell us a little bit about yourself, Tanya?
I am a nerd on the internet. I run a training company called We Hack Purple, and we teach all about AppSec and DevSecOps. So I'm really, really excited to see Farah's presentation. Nikki and I used to give a workshop where we would smash some JWT tokens. So I'm so excited to learn even more about it. And yeah, this is going to be a really good one.
Good stuff. We're excited. Nikki, your turn.
Hi, everyone. Nikki. I am also a project leader for OWASP DevSlop. And yeah, about the project, I mean, it's sort of growing organically, but its intent is to really show off like fun, interesting problems that happen with the new model of DevOps, DevSecOps. As that world shifts, we like to sort of follow that shift and sort of just talk about that new environment. So that's kind of what the spirit of the project is about. The way we do it changes. Sometimes it's software, sometimes it's podcasts, sometimes it's YouTubes. But yeah, that's what our goal is. So welcome, everyone.
Good. So
I guess I should tell you about myself. I didn't do that. But yeah, I forgot.
That's fine.
I missed my cue. No, I am a security professional. I've been in the industry for a very long time. Worked on the offensive side and now, corporate security management. Fun times.
She owns a whip now, several whips. She just runs around and she's like, you start validating your inputs. You can't turn off that security tested your pipeline. But she's very nice about it.
The most
carrot or stick.
It's most technical senior management that I know anyways. So since we're talking offense, I thought it would be a good idea to invite Rana to help us out. Why did we invite Rana? Tell us, Tanya. Who is Rana Khalil?
Rana's amazing. That's who. So she just got her second promotion in a really, really short period of time and is now a senior pen tester. Amazing. Wow. So she did her master's comparing all the different open source basically DAST tools, so like web app scanning, fuzzing, like automated web proxy, like a testing of web app types of tools as their masters, and then presented which ones were the best for various things. And I'm not going to spoil the answer for you. You have to read her dissertation, or get to know Rana. She also runs the Hack in the Box, the only one in Canada, with Nancy in Ottawa, which is amazing, the meetup. And she also actually did hack all the Hack in the Boxes and then blogged the entire thing so lots of people could learn. She's also a wonderful human.
Thank you.
My friend.
Welcome, Rana. We're happy to have you here. So
Happy to be here.
awesome. So I think it's time. Let's bring in our main guest, Farah. Hello, Farah.
Hi.
How you doing? Let me bring you in the main here. So what do you have planned for us? What is the agenda for today?
So today we're going to talk about JWTs, JSON Web Tokens. JSON Web Tokens are becoming really popular for authentication, and we're going to talk about the offensive side today, how to hack JWTs, how to break JWT authentication. This talk is going to be beginner friendly, so I'm going to cover only some basic attacks, but I'm also going to show you like a direction of where you can go if you want to learn more about some of the advanced techniques on how to break JWT authentication. But yeah, that's the agenda for today, hacking JWTs for beginners.
Super. So do you want me to share your screen at this point, or are you ready to do that?
Right.
I do not see it. I think it disappeared actually. Oh, here we go. Here we go. Is that it?
Yep.
Looking good. Perfect.
All right, shall we begin?
Let's begin. It's your show. Go ahead.
Okay. Firstly, I want to thank everyone for joining in. Thank you for taking your time out. Today, we're going to talk about hacking JWTs for beginners. So let's get started. Let me tell you a little bit about myself before we get started. So I'm an application security engineer at Bugcrowd, and I create content on my YouTube channel called Farah Hawa. I create technical content on mostly web hacking, and I also have interviews with some of the greatest bug bounty hunters that I know. And I'm also a part-time bug bounty hunter when I get time. So in today's talk, we're going to cover the introduction to authentication and JWTs. We're going to talk about the structure of JWTs, so what they look like when you open an application, what to expect. And then we're going to talk about the bugs. So there are a couple of bugs that we're going to talk about. These are mostly basic, like I said. So I think we can get started. So what are JWTs? JWTs stand for JSON Web Tokens. They're tokens that are signed, and they are mostly used in applications to authenticate users. So after a user enters a valid login, like a valid username or password, the application will assign them a JWT, and that JWT is based in a JSON format, and it also includes a signature to ensure the integrity of the token. So the signature is the most important part of the JWT, which ensures that no attacker can tamper with the token, and the integrity of the token is maintained. So what do JWTs look like? So what to expect when you see when you go to an application and you're looking for a JWT? So we're going to go to our lab. So if you want the lab, I think it'll be in the comments, and you can just Google Heroku app JWT lab and you'll get it over here. So I'm just going to go, and then you can go, you can sign up as a user over here on users. I've already signed up, so I'm going to go directly to the challenges. You can just pick any one for now because we're just going to see what a JWT looks like. I'm going to log in with my username and password. Make sure your intercept on burp is on. So when I log in, you can see that this is just my basic login request. And once I'm logged in with a valid pair of credentials, you can see that I've been assigned a JWT over here. So how do I recognize this? This JWT starts with an EY, and it contains of 3 parts, and these 3 parts are separated by dots. So you can see these 2 dots over here. There are 3 different parts to this. So let's go and see what these 3 parts are now. So the structure of the JWTs contains of 3 parts, namely the header, the payload, and the signature. So what does the header contain? The header specifies the algorithm which is used to generate the signature of the JWT. So like I said before, the JWT is a signed token, and the algorithm in the header specifies which algorithm the application will use to generate that signature. So here you can see that this is a base64 encoded blob. So this entire token over here is a base64 encoded string. So this is the base64 encoded header, and this is a decoded version of it. So this, as you can see, this is in JSON format, and there are 2 properties in this header. The first property is alg, which specifies the algorithm. So in this case, it's HS256, which is HMAC SHA-256. And there's also a type property which specifies what type of a token this is, which is of course JWT. So there are many different types of algorithm, but the 2 most common ones that you'll see are HS256 and RS256. Yeah, so let's see what the next part of the JWT is. So we have the payload. So the payload is the part of the JWT that actually does all the access control stuff. So it contains all the information about the user. This really depends from application to application. There's no fixed data that you will see common in every application, but it generally would have like a user ID or a name, email address. It can also have the privileges of the user, so whether they're an admin or whether they're a normal user or a super user. And this last property that you see over here, IAT, this means issued at, and it's a timestamp. So it's a timestamp of when the JWT was issued, and this helps with stuff like expiry of the JWT. It makes it easy for the application to do that. So the last part is the signature. So how is the signature calculated? Like I said, this is the most important part. So first, the application concatenates the base64 URL encoded header and payload. So the header is base64 URL encoded, the payload is encoded, and then they're concatenated and they're separated by by 1 dot. Then it uses the secret key. We're going to go into detail about this a little bit later. But yeah, so there's a secret key that's used to generate the token. And finally, the algorithm mentioned in the header will take this entire blob, and then it will generate a signature using that algorithm. So as you can see, this is quite a complex looking piece of code. And imagine a user trying to change his or her details in the payload. So what if they try to change their username or name from Farah to admin? Are they going to be logged in as the admin? So the signature will prevent that from happening, because even if the user knows the header and the payload, there's no way they can know the secret. So they can't generate a valid signature for that application. And if they can't generate a valid signature, they can't generate a valid token, and they can't use that token to log into the application. But this does not mean that JWTs are completely secure. So that's what this talk is all about. We're going to explore ways in how we can fool the application into simply not checking our signature, or we can switch up the algorithms and confuse the application, or the application might have security misconfigurations in itself, which might allow an attacker to forge their own token. So let's finally get to the bugs, and we're going to do a demo of all of these on the lab that I showed earlier. So let's get right to it. So the first one is the null algorithm attack. So believe it or not, JWT supports a none algorithm. So you can imagine that if the algorithm field is set to none, then any token will be considered valid and you just have to leave the signature section blank. And then attackers can forge any token that they want and impersonate any user by using that forged token. So here are the steps. So after logging in, capture any request and send to repeater. So we have already captured a request over here. I'm just going to send this to repeater. Also make sure that you are on the none algorithm lab. And we can see that the goal of these labs are to register a user and then gain access to the admin user. So I've sent it to repeater right now. And you can see that here the current user is ftest, which is my username. So we have our JWT token over here. Let's send it to decoder so we can see exactly what we're working with. So this is the header. We have let me show it in text. It's a bit more readable. So this is the header, which is RS256. Then we have the payload. In the payload, this only has my username, which is ftest. Also, if you don't want to send it to decoder and if that's too much of a hassle, there's also a great extension on Burp called JSON Web Token. I'm sorry, this is really tiny, but I can't help it. This is just the extension. So this automatically decodes your JWT for you. It tells me my header, my payload, and my signature. So what I want to do is I want to log in as the admin, and this is the none algorithm attack. So I'm going to set my algorithm to none over here. I can do this manually, but this JSON Web Token has a great option inbuilt. So I'm just going to change it to none. And I need to change my name to admin. So once that's done, I'm going to send it. And let's see if we're logged in as the admin. So yeah, as you can see, the current user is admin. And you can see the JWT on the request that it only has two parts now. It only has the header and the payload. And because I've set the algorithm to none, what's happened is the application basically is instructed to not generate a signature for this. Now, keep in mind that the none algorithm attack was only meant for testing purposes or for debugging purposes. It was not meant to use in production, but it might be possible that the application must have forgotten to disable it, or it's just enabled by default. So you might get lucky by trying this attack. Let's move on to something else. So apart from the none algorithm, we talked about the HS256 and the RS256 algorithms. So let's compare them for a minute over here. So what does the HS256 algorithm do? It basically symmetrically signs every token. So it uses the same secret key to sign the token, and it uses that same secret key to verify the token. But on the other hand, RS256 asymmetrically signs the token. So it signs the token using a private key, which is not accessible to anyone, and it uses a public key to verify the token, which could be accessible to some people. However, the HS256 maintains that secret key as a secret, and none of it is accessible to anyone. So how can we exploit this behavior? So if an application expects a token with an RS256 algorithm, it means that it's signing the token using a private key and it's verifying the token using a public key. But if we change the header, if we change the algorithm in the header to HS256, this means that we can sign our own token using the public key, which could be accessible. And because of the symmetrical nature of HS256, the application will verify the token also using that same public key. So I know this whole concept could be a little bit confusing, and it's a little bit hard to present it on a talk, but I have a YouTube video on this topic where I've explained it with a lot of animations and codes. So if you're confused, then you should watch that and you will probably understand a little bit better. So let's do the demo for this. We'll change the algorithm from RS256 to HS256. So let's go to the next lab. We have to go to exposed key. So I'm already logged in once. I have the same goal over here to register my user and gain access to the admin. So what we're going to do is we're just going to save this key in a file called public.pem over here. I've already done that. And what I'm going to do is, so after logging in, I need to capture any request and send it to repeater. So I'm already logged in. I'm just gonna refresh this and send this to repeater. Now I've already downloaded the key and saved it as public.pem, and now I have a code over here. This code is on my GitHub in case you want to do this. And what I need to do in the code is change the header, the algorithm property in the header to HS256, and the payload, the name, I need to change it to admin. So I'm going to go to my code over here. So these are just some libraries that I need to import for generating my signature. And then I need to open my file with the key. I'm going to add my header and payload here. So basically what I'm doing is just generating my own signature. I'm generating my own valid signature, which will be verified by the application and it will be valid. So I'm going to change my payload to admin, and this is my encoded header. This is my encoded payload, and I need to concatenate my header and payload here. And then I'm going to create my signature. And finally, after everything is done, I'm going to concatenate my token with the signature and generate a valid token. So let's run this. So like you can see, I have my token over here. So I'm just going to copy this and I'm going to paste it over here.
Farah, any chance you can make your font in your VS Code just a tad bigger?
Sure. I can't seem to find the option.
Sometimes if you press the command and then the plus, it'll just do it for you, if that makes sense. I mean, sometimes
Yeah, it works in VS Code.
So like the command button. So like if you're in Windows, it's the Windows button. If you're in Apple, it's the Apple button.
Okay, got it.
Oh, it looks so good. Thank you.
There you go.
You're doing great, by the way. Like everyone's like, this is awesome. Everyone in the chat is like, yeah. And then we've been sharing your YouTube channel and your Twitter channel so that everyone can follow you. So sorry to interrupt you. Please go.
No worries. I'm just going to go through the code once again because I think it was too small to understand. So I'm going to import all the libraries necessary for generating my signature. Then the file that I saved earlier, I'm going to open it in this code. Then the header and the payload to generate my signature. So HS256, and I want to log in as the admin. So this is going to be admin. This is my encoded header. This is my encoded payload. Then I'm concatenating them with a dot in the middle. Then I'm creating my signature using all libraries that I imported earlier. And finally, after everything's done, I'm going to concatenate my token with the signature, and I'm going to put a dot in the middle. And I think I already copied it, so I already pasted it as well. So I'm just going to send this. And let's see if we are logged in as admin. Yeah, so you can see that current user is admin, and let me just show you this on the browser as well. So we can show the response in browser. Yeah, so you can see that I'm logged in as the admin. So basically what I did is I switched up the algorithms, confused the application, and used the public key that was exposed. So just to summarize, that if the application is expecting a token that's signed with RSA, but it actually receives a token signed with HMAC, it will think that the public key is actually an HMAC secret key. And then this allows attackers to forge a token and impersonate any other user on the application. So let's go to our next attack. Now, this may seem really silly, but I promise you, I have seen this on a lot of pen tests that I've done. So this is simply a...
One sec,
Yeah.
sorry, there's a question in the chat. Where would you get the .pem file, like in a real engagement? Do you know what I mean? Because sometimes, like, you're trying to get the .pem file, but like, where would you look for that? How would you find it?
That's a really great question. So let me just go over here. So there's this thing known as JWTs.json, and this is basically a file which is like a key set which might be exposed on an application. So like you have all these backup files or config files, this is something very similar to that. So you can find this like this HTTP, your domain, or some path and JSON. It might just be exposed. But apart from that, this is not the only way you can find it. You can also find it through just like basic recon, through maybe going through your Wayback URLs, or through or you might find it in a JavaScript file. It could be exposed anywhere because it's not really a big security concern if a public key is exposed, right? So you might find it anywhere. But the JWK.json is probably, I mean, it's probably the most probable option. Does that answer your question?
Yeah, I think that was great. Thank you very much.
All right, so we'll move on to the next attack. So again, like I said, this is a silly security misconfiguration. And what the developers usually do is that they don't verify the signature of the token when it's received by the application. So an attacker can simply just remove the token or just provide an empty string. It doesn't matter, it will still be valid. So again, after logging in, capture any request, send it to repeater, and then you just have to remove the signature section and change the name property to admin. So make sure you go to the next lab now, which is signature not checked. I'm currently logged in as ftest. So it's written over here. Some lazy developers don't even check the signature. Crazy, right? It is true. So again, I'm going to refresh it. Send this to repeater. I have my JSON Web Token extension over here, but I'm just going to change my payload to admin.
What programming language are you using for the demo in VS Code?
That's not the demo. This is just the code to generate my signature, but this is in Python.
Cool, thank you.
So I'm just going to remove this signature. I can just like leave it. I mean, I can keep it an invalid string as well, and it doesn't matter, but I'm just going to remove it. So let's send it. And you can see that again, I'm logged in as the admin, and same, like there is no signature, but it's still logging me in as admin, and I did not change any algorithm over here. I did not change it to none or anything. It's just simply not checking it. So I think this is the last attack that we have for today. So this is brute forcing the signature. This will only work when the algorithm is HS256 because, as we discussed earlier, since HMAC uses the same secret key to sign and verify the token, it's possible to brute force that key, and you might be able to generate your own signature. And it's not that difficult as it sounds, because when you think about it, you already know a lot of information. You already know the header, you already know the algorithm, you know you have your payload with you, and you already know what a complete signature that's valid looks like. So when you think of it as a math formula, you have all the ingredients except for one, which is the secret key. So it's really easy to brute force that. And especially if the developers have used a weak key or a common key that's probably in some common word list, then it becomes very easy. And I'm sorry I do not have a demo for this one, because I'm afraid that my computer will die if I do a brute force. But these are some amazing tools. So there's Hashcat, there's JWT Brood, JWT Cracker, and these are all the links to them. So you can definitely try this attack out yourself. And there is a challenge available over here called weak signature, which you can use. Yeah, so that's all the attacks I have for today. Let me summarize my entire talk over here. So, firstly, we learned that JWT contains three parts: the header, the payload, and the signature. Header contains the algorithm, which the application uses to generate the signature. Payload contains information about the user, and signature is the most important part, which maintains the integrity of the token and it prevents attackers from tampering the token. Then when we look at the attacks, the first one is the null algorithm attack, which makes any token valid even if the signature is left blank. When we change the algorithm from RS-256 to HS-256, and we have the public key that's exposed, that can also allow an attacker to forge their own token. And lastly, providing an invalid signature or brute forcing a weak key could also allow an attacker to forge their own token. And like I said, these attacks were mostly basic for beginners, but there are some great resources. So all of the exercises on Pentester Lab, I think they have about, I mean, I don't know, I think they have about 5 or 6, but they're all really good and they cover a lot of advanced attacks as well. WikiLee's JWT blog is also great. It's very beginner friendly. I love her blogs. And lastly, there's Auth Zero's JWT blog about the critical vulnerabilities in JSON Web Token libraries. So that's all. Thank you for watching this and have a great day.
Oh, we have plenty of questions in the chat for you. But of course, before we go there, we announced that we would have a giveaway for Pentester Lab, and we did not lie. So I just want to share the link with you. We have two 1-year subscription to give away, but we won't make it that easy. We have a quiz for you, making sure that you paid attention to the presentation. And if you get a perfect score, you get in the pool to win one of the 2-year subscription to Pentester Lab. If you're just participating, whatever your answer, whatever your score, we have 3 subscription to Pentester Lab for 3 months each to give away as well. So the link is on the screen and it will be in the chat very soon. And let's go through the Q&A and questions for Farah. And by the end of the show, I'll be able to announce the winners. So let me go back, see everybody. How's everybody doing? So any question in the chat, Tanya, Nicole?
So there's
Scrolling up.
Yeah, there's so many questions. Everyone says thank you, and that was absolutely amazing for starters. And I'm just sharing all of the really great articles. So a lot of people are like, wait, I didn't type out that article fast enough, and I really, really want to read all of them. We also shared your YouTube channel to make sure that people get it.
I got a good question here from the chat. Are you ready? Okay. How do you find the public key of the algorithm?
Oh, I think I already told that, but you can find it in the JW keys .json file. You might find it in a common path. So in the same way that you find some config files or backup files leaking sometimes, this file could also be publicly exposed. And the thing is that it's not a huge security issue because it's supposed to be a public key, right? So even if like it's pointed out, it might not be like taken off by the developers. But also you can find it through like traditional recon, like wayback URLs, JavaScript files, and just get creative with recon. You might also find it. But the JKS.json file is probably the best option to get the file.
And those could be in directories like .well known, things like that, because they're meant to be publicly consumed by things that need the public key, right?
Exactly, yeah.
Okay. All right, let's see if we have some more. Hold on. There's a lot of scrolling that I'm doing here. So
There's so much stuff in the
Yeah.
chat. Like it's literally just so much. It's like just scrolling off the screen over and over again. And it's lots of like, thank you, that's cool. And what is her YouTube channel again? And so we've shared that.
Also, I think we talk a lot about the defense, so it's great that we know that now JWTs are vulnerable, but we'd also like to know what would be a good secure implementation. And I think either Rana or Farah, if you have anything to say about that, that would be super awesome. Go ahead.
Do you want me to go first, Farah?
Yeah, sure.
Up to you. Yeah? Okay. All right. So I counted 4 vulnerabilities that you mentioned. I'll start off by saying, in general, JWTs are inherently insecure compared to how we used to do session management, which is just using a long random ID that expires and is put in a cookie or whatnot. So compared to that, JWTs are considered inherently insecure. The 4 vulnerabilities that you mentioned, 2 of them, which was the non-algorithm and then the algorithm confusion, where you switched RSA with an asymmetric encryption. Those 2 are caused because you're trusting user input, so client-side input, and you're not validating it at the back end. So they could be library specific. It depends on whether the library supports that or not. But if it does support that, what the library needs to do is verify the encryption algorithm at the back end. When it gets it. So even if it gets it, when it gets it from the client side, it also needs to verify that that's the one that the backend was also accepting. And if it doesn't, then you throw an exception. You present the user with a generic error message, and then you log it because it's clear attack against your application. So those were the first 2. The third one, I think, was the you don't check the signature. That's a mistake from the developer's end. So I've seen it happen as well, where you decode it, and as long as it's with the correct format, it'll accept it. So as long as the JWT is with the correct format, it doesn't actually verify the signature. So make sure you verify the signature, because other than that, like, the JWT is effectively useless. You could trivially change it, and like the application will accept it. And I think the 4th one, if I remember correctly, was cracking the token. And that's just like, you have to use strong passwords for applications. In the same sense, this is even more dangerous because this is a key that generates everyone in the application, every user of the application, it generates their session IDs. So that key needs to remain secure, and that key needs to be long and random. If you're using symmetric encryption, I think OWASP recommends 64 characters. And then, of course, you need to rotate the key and so on. Or what you could do, which is a better option, is just use asymmetric encryption, because that's more secure by default. Yeah, those were the 4 vulnerabilities. I think I covered all of them. Did I miss anything?
No, I think that was,
yeah.
I think that was pretty darn thorough.
Yeah.
Awesome. And also I shared that Heroku has a lab on JWT tokens as well, and of course Pentester Labs. And so does the Pentester Labs lab on JWT tokens, does it cover more than what you covered in your talk?
Yeah, it covers a lot more than that. They have a lot of advanced topics, advanced attack techniques. So yeah, that's definitely a great resource for JWTs.
Super cool. Thank you.
There's 2 good defensive related questions in the chat. I think they might be for you, Rana, or actually anybody.
Okay.
All right. How do you make sure that if a JWT was stolen, it can't be used on another device?
That's a great question, because it's a huge problem with JWTs. So if you don't have a revocation list implemented at the back end, you can't make sure that, because it's inherently the JWT does not expire until the expiration, if you set an expiration date, until that expiration date passes. And so it can be used whenever you want. And that's because unlike normal sessions, it's handled on the client side versus on the server side. And so unless you have some kind of revocation list on the server side, it won't, you'll be able to use it as much as you want. So in terms of revocation list, what you would do is, and that's one implementation, you could if you want to revoke a JWT, you could hash it, save the hash in the revocation list, and then keep that hash until the expiry date of the token is done. And so once the token expires, the user can't use it anyways, but until it expires, you could have that in that revocation list. And so you'd have to check every token that goes in there on the server side to ensure that it's not one of the revoked tokens. Yeah.
Thank you. That was great. More questions. Lots more questions.
Someone in the chat is like, Farah, can you help me cheat and answer the Pentester Labs quiz? I'm like, no, Farah's not going to help you cheat.
You can watch my video. That will give you a quick brief of everything.
Yeah, the answers are in there, in your video and in your presentation, so for sure.
Also, people are asking if you have a newsletter or a way they can keep up with you besides just subscribing to your YouTube channel, which obviously everyone already did, and following you on Twitter. Are there more ways they can keep up with you?
Not as of now. I mean, YouTube is a lot, but I am thinking of coming up with a blog, like to just put all my YouTube videos in one place for people who like to read, prefer reading over watching video. So you can be on the lookout for that. But apart from that, I think YouTube is the only way that I can be in touch with everyone.
That's cool. That's cool. Does the DevSlop team have a way that people can keep up with us? Nancy?
Of course. We're everywhere. We're on Twitter, LinkedIn, Meetup, and our YouTube channel. If you subscribe, you get a notification. So all of them, you don't have to sign up to Meetup, but it's a great way to know what's coming up, the different shows that we have coming up. So we're not done with Farah yet, but I'll interrupt a few seconds just to show you. So that's what we have coming up for in 2 weeks on the 25th, AppSec at the Speed of DevOps with Eric Anderson coming all the way from Australia. So if you're interested in content for DevSecOps, we talk a lot about defensive security, but sometimes we have a great guest like Farah to tell us about the red team side of the offensive side of things. But yeah, follow our content on Meetup and everywhere else. And in 2 weeks, we have this presentation. What else? Any more questions in the chat, Nikki?
There's a few questions. There's a question about OAuth, but I think that's a little bit out of scope, so we're not going to get into that one. A question about how often you should rotate symmetric keys. That's, I don't know. Rana, you want to?
I actually don't have advice on that one. It would depend on the organization. I don't know.
Yeah, I don't know either.
I feel like that's a really complex question, and it really depends on what risks you have for your keys, right? Because like, do you want to have the same key a decade later? Probably not. However, I mean, what is the key used for? How much exposure does it have? Do you know what I mean? Like, is it internal on a secret network that has like, that's air gapped and blah, blah, blah? Or is it like one where it's out in the public and you're not really sure how everyone's doing with it? But every time you have an incident, rotate. Yeah. If there's possible exposure, rotate. If you get notice on your bug bounty program or via if you have like a coordinated disclosure program, that thing might have a vulnerability around it, rotate. If there's any question, rotate, even though it sucks.
And it's not as easy as it seems, though, right? Because then either all the JWTs won't work, or you have to keep track of multiple keys, and it's just like a whole issue. So, yeah, complex question.
Oh, there's a nice question that I like. Did you find, Farah, did you find these vulnerabilities in real life, or was it when you were testing for a bug bounty program?
So I've never found them in bug bounty programs, but like I said, I found a lot of these in pen tests. I found the none algorithm one and the invalid signature one a lot. I've never tried brute forcing the signature, honestly, but yeah, the other two, the ones I found in pen tests, they do exist in applications, like live applications in production.
Do you know of any automated tools, like maybe, I don't know, a linter that would be able to verify that a JWT has been implemented correctly? And like, isn't this the story of our entire industry? If only if we had like spell check for code, right? Are you aware of any specific tool? Because I'm not, that could check specifically the JWT to make sure it's implemented correctly, besides a pen test.
I'm not really sure, but I think the burp extension that I showed earlier. So if you try to provide it does have an option to provide an invalid to provide a signature of your own. I didn't use that, but it does have a feature. But if you put that, it tells you whether it's a valid signature, if it's expired. So basically, what you said, has the key been rotated? Has the key been changed, or does it still exist? So it does do, but it's not. I couldn't call it an automated tool that could do it for you. I mean, you would still have to go out and check it for yourself manually.
Okay, let me interrupt you guys just to declare the two winners we have. Where's my screen? I thought I shared it. Okay, let me try again. So here's our random name picker. So I'll go with the first two. Those are the ones that had perfect scores.
I love that it's rainbow.
So here's our first winner for 1 year of Pentester Lab. And let's go for a second one.
There are a lot of people doing the fingers crossed emoticon in the chat.
Here we are, 2 winners for the perfect score. I have 3 more to give away. I'll interrupt a bit later and bringing everybody else in the pool for the winners. Keep going with the questions, please. Oh, it's not good. Okay. Are you all done with the question? Nobody else has said anything?
So one of the questions, is it really Tanya in the chat? And yes, it's actually me typing those things. That's why I'm not saying a lot.
Someone pointed out a good point, which was don't add sensitive information into a JWT token. And I've seen this many times. I don't know if anyone wants to comment on that, but why do we? I mean, it seems pretty self-explanatory. It's not encrypted. It is encoded, which means you can reverse it trivially. So that's the core reason why you don't want to do that. I have seen weird implementations where people actually encrypt the payload inside the JWT token. It's a little non-standard, but people do that. But essentially, sensitive information in a JWT token is a no good situation.
Yeah, there's a new version of, like the newest version of JWT tokens, and it allows you to encrypt the payload. But I haven't seen tests on it to see if it's actually good or not. And also, what if you just passed like stuff in a secure cookie like everyone else does, because that's good, and not put it in the JWT token, which has lots of known vulnerabilities and problems.
I think cookies come with their own problems as well, right? Like cookies have their own issues. CSRF is relatively like easier to do with cookies. With a JWT, it goes in with the authorization header, and then that becomes like, that's not easy for a CSRF attack. So, and I think JWTs also are, the point of them is that they're self-contained, and the cookies are more a reference where they go to the server references them against something and then returns the data related to that. Whereas JWTs are more self-contained. They have the information. The server doesn't need to check every time what is the data corresponding to it. It's not a reference.
Yeah, I think it depends on your organization, what you prefer, right? There are advantages to both and disadvantages to both. So it really depends on the organization. In both cases, like sensitive information shouldn't be put either in cookies or in JWTs, whether they're in cookies or whatnot. But yeah, and one other thing that I think was not mentioned was the JWT where it's stored. So you mentioned the authorization header, putting it in a cookie that is secure and has the HTTP only flag set on it and the proper domain attribute as well would be good. Putting it in something like local storage would be horrible because JavaScript can access local storage. And I've personally seen that in pentests where it's being stored there. And that's so much more accessible in by JavaScript than it would be if it's in a cookie that has the HTTP only flag set on it. Yep.
Nice. Can we announce the names of the winners again, because everyone is still asking about it? And also someone is saying, can you re-enable the quiz so they can just practice on it because it's fun? Which I think is great. And also someone else is asking, Farah, do you speak Hindi?
Yes, मैं हिंदी बोलती हूँ.
Yes, awesome. Do you also speak Punjabi?
No, not Punjabi. I can understand a little bit, but I can't speak. I can speak Hindi fluently. That's what we speak at home.
Cool. That's okay. I can't speak Punjabi either, so don't worry about it. Awesome. So, Nancy, will you say who the winners are again out loud, just for anyone who, for the 500th time, has not heard?
No, I'm actually past the 2 winners. Like the wheel has reset it, but I'll announce the 3 other winners and contact the winners. I have their email and we'll be able to contact them and let them know they won. So if you get an email from me in the next 24 hours, it's because you won. If you didn't, it's because you didn't. Okay, so let me share that with you.
So what are they winning now?
Now it's still a Pentester Lab subscription, but for only 3 months. And Eric, you see, like there is so many names. That's why I had to stop eventually because they kept adding, stop getting new names. But everybody's in, whether you had a perfect score or not on the quiz. Your name is in there before. So here we go. That's our first winner of the 3-month subscription. That's the second winner. And number 3. So again, thank you very much for participating. I can reactivate the quiz now that the winners are in. And you can have fun with it. But thank you for participating, and you'll be getting an email from us really soon. Let me stop sharing my screen. Awesome.
If people are very concerned about how they did not win, you just have to come back and keep watching our show, because we give away things on lots of different episodes. And so, yeah, just come back. First of all, subscribe.
Yeah.
Join our meetup. Hit the like button, and then send Farah fan mail. That's how the process works.
Yeah, I should have a checklist in there. Awesome. Okay, well, thank you, Farah. Thank you, everyone, for being here. We'll wrap up. Thank you for everyone who participated in the giveaway. Thank you to Pentester Lab. Louis was super generous to give us all those subscriptions for everybody. So we're really happy to collaborate with him. So that's it. Again, we have a show next week, not next week, in 2 weeks on the 25th of October. I will share that again with you. AppSec at the speed of DevOps, 3 common mistakes. You have everything that we've discussed today that is relevant and important. I will take all that information and put that in the description box below so you can keep looking for it in the next 24 hours. if you need anything else, contact us through our Twitter account where our DMs are open. So I'll do a last round with everybody on the stream. If there's anything to add, anything you have to promote, or anything that you're doing, and please let us know. So,
someone's asking about my book. So I did not bring it up, but someone in the chat brought it up. So what else can I do? So I wrote a book, and it is called Alice and Bob Learn Application Security. And I just put the link to buy it on Amazon. And if you can't figure out how to ship it to your country, I will help you figure it out. And it is about basically Alice and Bob learning application security. So it starts at the very beginning and it goes all the way to the end, and it covers an entire chapter on all sorts of different types of testing. But there's more to AppSec than testing, as you'll see, as so many bad things happen to Alice and Bob when people don't use security headers or people don't secure their tokens. Oh, no. It's not a fictional book, though. It is a textbook with lots of stories in it. Thank you so much. And thanks for bringing it up. I love how Nancy has added so that we have like our names in lights underneath us now. It makes me feel very fancy.
It's a lot of fun for me. Rana, your turn. Anything that you want to tell us about? What are you up to these days? Writing any more Hack the Box write-ups?
Just the ones for the Hack the Box Ottawa chapter. But no, trying to focus on the OSWE, which is very, very difficult during COVID-19 and working from home and being in the same place when you're studying aside from work and all that. So yeah, just focusing on focus. Oh yeah, 100%. Because like there's no change in environment, right? First you went to work and that was one environment, and then you came back home and it's a different environment. But yeah, now it's like super difficult, but I'll get there. So yeah, that's what I'm up to. Great presentation, by the way, Farah.
Yes.
Thank you.
Keep mentioning the Hack the Box meetup that Rana and I organized together. It's a lot of fun. So if you're not part of our group, join us as well. Let's promote that. That's awesome. What about you, Nikki? What's up with you?
Well, I think I'm gonna kick up a blog that revive a blog that I had about 10 years ago that I've lost all the content to, but I don't know. I'm kind of bored during COVID-19, so I'm trying to give myself new challenges. So look out for that when I eventually post my posts.
I'm looking forward to it so much. Excellent. Thank you again. Okay, so that's it. Thank you very much, everybody. Have a great afternoon, night, morning, wherever you are in the world. I know it's late for you. I think it's about like 11 p.m. for you, Farah. Is that it?
Yeah, it's almost 11:30 now. Yeah.
Perfect. Oh.
Thank you, Farah.
Okay. Thank you for doing this, and thank you for everyone. So that's it for now. Bye, and see you all in 2 weeks.
Bye.
Thanks, guys.
Bye.
Pentester Lab Pro makes learning web hacking easier. It covers everything from basic bugs to advanced vulnerabilities. Not only will it help you learn, but you'll also have fun doing it. There's only one way to properly learn web penetration testing, and it's by getting your hands dirty. You'll learn important concepts, not just another bug. You won't need a complicated setup. A browser and a web proxy like Burp or OWASP is all you'll need. Don't wait any longer. The introduction badge makes it super easy to get started. Subscribe to Pentester Lab Pro and get to the next level.